Welcome to our review lesson on scale drawings. As a review, I've put two vocabulary words that we already learned in previous lessons. So scale drawing is an enlarged or reduced drawing of an object that is similar or proportional to the actual object. And then scale, which we can also call scale factor, is the ratio that compares a length in a drawing or model to the corresponding length in the actual object. So again, as we talked about before, the drawing comes first and the actual or the real object comes second. Here's an example. If a 20-foot statue is 1 inch long in a drawing, you can write the scale of the drawing in 3 different ways, remembering that we need to put the drawing first and the actual second. When we talk about scales or scale factors, it's very important that we label. So the drawing is 1 inch. So we're going to say 1 inch to 20 feet. Or we could show it using the fraction bar, 1 inch to 20 feet. And the third way that we could actually show a scale is by using an equal sign. So 1 inch equals 20 feet. Now this makes sense because what we're saying is that in the picture, 1 inch is the same as equal to 20 feet. All right, let's go ahead and give it a try. It says the length of the side of a house is 3 centimeters on a scaled drawing. What is the actual length of the side of the house? Well, right here we see our scale. 1 centimeter is 2.5 meters in real life. So if the length of the side of a house is 3 centimeters in the drawing, what we can set up is a little proportion. Now on the side of the proportion, just to remind myself, I'm going to write drawing, which is in centimeters, compared to actual, which is going to be measured in meters. Now because I wrote my labels here on the side, I don't have to write them in my proportion, but usually it's easy for me to label later on if I label in the proportion. So I'm going to go ahead and label 1 centimeter per 2.5 meters equals, and then in the drawing it's 3 centimeters. So I'm going to put 3 centimeters compared to, we're not sure how much that would equal in real life. So from here all I need to do is cross multiply 3 times 2.5, which is 7.5. And again, right now I'm ignoring the labels. 7.5, and then 1 times x, which is just regular x. And now I need to add my label. Because x was on the bottom, centimeters and centimeters were on top, meters and meters are on bottom. So it's 7.5 meters. Now, there are a few variations on the way that you could set this up, but typically what I do is drawing compared to actual. All right, question number 2. It says the actual length, L, of a rectangle is 122 inches. Use the scale drawing of the rectangle to find the actual width, which is the W. So what I'm going to do is, again, I'm going to set up the drawing to the real, or the drawing to the actual. And these happen to both be in inches. Now I'm going to take what I know and I'm going to create a proportion. So the drawing of the length is 6.1. And then the drawing of the width is 1.8. Because I have inches labeled over here, I don't necessarily need to put them in here, but again, you can if you would like to. It says that the length of the rectangle is 122, and that's the actual, so I'm going to put 122 below the length of the picture. And then we don't know what the width is, so you can put x or w or whatever you want. And then all we do is go ahead and cross multiply and solve. So 1.8 times 122 is 219.6, and that's going to be equal to 6.1 times x, which is 6.1x. From there, it's just a one-step equation, so I divide by 6.1 on both sides, and of course you can use a calculator for this type of calculation, and it's going to say 36 inches equals x. All right, the back side is up to you, and I hope you enjoyed our lesson. Thanks.